This is math, advanced math 12.3, and the title is Logarithms and Log Laws. All right. So we're introducing logs today, and this is what they're going to look like. First off, I'm going to write this. This is something we've done before. B to the x equals a. And how did we solve these before? We've done something like this. 2 to the x equals 32. We got them to have the same base, and we solved. 8 to the x equals 32. We got them to the same base, and we solved. Sometimes our answers are whole numbers, fractions, negative numbers, but we know how to solve. Questions on what this looks like. B to the x equals a. All right. Today we're still going to have them where we can work them out like this, but eventually they're going to look like 2 to the x equals 27. If this is 27 instead of 32, could you write them to the same base? 2 to the x equals 15. What do you do in those cases? We're going to learn a different tool. So these are equal to each other, and this is what it looks like. Log base b of a equals x. Okay, so you can go both ways. This to the log or log to the x. This is called exponential form, or yeah, and the other one's called logarithmic form. Exponential form is what I meant to say. Exponential form and logarithmic form. Okay. So when you see this, first off, make note that the log, the a, the x are all in the same line. The b is this base b. It's like the exponent, but at the bottom. And you read it. You don't. This does not mean b to the a power. That is not what it means at all. You read it as log base b of a equals x. Log base b of a equals x. Got it? All right. Now, what do we do with that? We're going to learn today how to work with logs. Okay, there's a few things in both cases that a cannot be and b cannot be. Okay. Let's start with the b. There's 3 things that b cannot be. B cannot equal 0, b cannot equal 1, and b cannot equal a negative number. So whether it's b here or b here, b cannot equal 0, 1, or a negative. A could equal 1, but it can equal 0, and it cannot equal a negative. A could equal 1, but it cannot equal 0 or a negative. All right. These restrictions here, we're not going to use too much today, but we will come to a point where we're solving, and we need to know these rules here. The things that b cannot be and a cannot be. All right. Evaluate. Number 1, log base 2 of 32. Okay, yes.
You said a can equal 1.
It can, yes. A can equal 1, but a cannot equal 0, and it cannot equal a negative. Her question was, could a equal 1? Yes. B cannot, but a can. Okay, so this does not mean 2 to the 32nd power. We're going to rewrite it like this, which means this says evaluate. It does not say solve. We will be dealing with solving next week, but I am going to make it equal to x, so I am going to make it an equation so that I can rewrite it. So I'm going from here to here. And I write it as 2 raised to the x equals 32. Remember what I said earlier. Here you're asking yourself, b raised to what power equals a? So what we're doing is what I call the wraparound. You wrap around the equal sign like that. 2, wrap around to the x, come back to the log side. And when you wrap around, you drop the log. Just like if it's a square root and you square both sides, that square root's gone. Here, when I wrap around, the log is gone. I do not write the log anymore. All right, this looks like the one I showed you over here, the one we did last week or a few weeks ago. 2 raised to what power is 32? You could do it in your head. I'm going to write it to the same base. 2 to what power is 32? I just showed it a few seconds ago. 2 to what power? 5. That is one you should eventually have memorized. Once you get them to a single, same base on each side, you can drop the bases. X equals 5. Technically, there's no x, so it's just 5. If you put x equals 5, I'm perfectly fine with that because I know that's how we're working it out. Questions on number 1? All right. Number 2 is log base 29 of 1, and that's it. Log base 29 of 1. So this goes to that question that Brindley asked earlier, can A equal 1? Where is the 1 at, in space B or the space of A? And is it okay for A to equal 1? Yes, B cannot, but the base cannot, but A can. All right, set it equal to X and wrap it around. And that's 29 to the x power equals 1. This is a special case when it equals 1. Yes.
Couldn't B equal 1 if A equals 1? So no matter what you put in, it'll still be 1.
I'm not sure what you're asking me. Repeat it.
Like if log base 1 of 1. Because you could put in any number for x and it'll still be 1.
Yes, but it doesn't always work. Log base 1 of 5. Let me address your question. Let me do this one, then I'll address your question. Okay. So 29, I'm going to, instead of changing the 29, I'm going to change the 1. 29, not 20, 29 to what power is 1? 29, okay. What's my exponent here that's going to give me 1? 0. Do you guys agree that 29 to the 0 is the same as 1? So I'm not changing its value, I'm just changing the way it looks. 29 to the x is still there. 1 is still there, it just looks different. What's my answer? Drop the bases, x equals what? 0. Do you guys agree that 29 to the 0 power would give me 1? Yes? Would that work with any base? Log base 10 of 1. 10 to the 0 power is 1. Yes, so it works for all of them. It doesn't work for these because we can't have 0, 1, or a negative number for a base. Okay, addressing your question. Any questions here before I address this question? Okay, you said log base 1 of 1 would work because we said that A could be 1. Right? Is that what you're saying?
Yeah.
1 to what power equals 1? And that is 1. Yes, but it has to work for all of them. Log base 1, pick a number here other than 1. 2. We actually just did this one today in my Math 3 class, something just like this. I said it equal to x. 1 to what power is 2? Is that going to work? No. And it has to work for all of them, not just for one case. So do you guys see why the base cannot equal 1, but A can? Okay, so questions on his question that he had? None? Okay, moving on. Number 3, does that answer?
Yeah.
Okay. Number 3, log of 0.0001. Now, I have not gone over this with you, but you, every single one of you in this classroom learned it last year from your Math 3 teacher. I did. What did you say? Was that you? I did teach this to you. I'm gonna go back and watch those notes. All right, your Math 3 teacher taught this to you, but it's been a while, so you may not remember. How many of you remember doing logs last year? How many of you vaguely, like remember seeing it but don't know how it works? Okay. Does anybody remember what the base is when they don't write it? Your teacher told you this last year. Yes. 10. Good job. Does anybody remember that now? That he said it? If the base is not there, the base is 10. So set it equal to x and wrap around. Here and wrap it around. 10 to what power gives me that decimal? We did these that before spring break. 0.0001 is 1 over what? Figure out what decimal place it is in. 10,000's place? Yes, so 1 over 10,000. Okay, and then I bring it up with a negative exponent. So 10 to the x equals 10 to what power? Count your zeros. How many zeros are there? 4. So is it 10 to the 4th or 10 to the negative 4th? Negative 4th. Why? Because I'm moving this up to the top and it makes it a negative exponent. Drop your bases. What does x equal? Negative 4 is your answer. Got it? Okay. Number 4. Oh. Nope, no number 4. Before I move on, any questions? All right, what I'm going to do right now is go over log laws. These log laws we're going to use the rest of this unit and on the final. All right, we're going to use it not only in this lesson, the rest of this unit, as well as on the final. Okay, here's how log laws work. You do need to have these memorized. Okay, I'm going to write them down. I'm going to write, well, there's 3 of them, 1, 2, 3, and then I'll write what they equal. Okay, number 1, log base b of I'm going to erase this. Log base b of m plus log base b of n number 2, log base b of m minus log base b of n, and number 3, log base, and I'm going to put a k in front, k times log base b of m. K times log base b of m. And I'm just going to rewrite it because it's a little crowded there. You do not have to rewrite yours. Okay. K times log base b of m. Okay, now what does each one equal? Okay, this first one can be rewritten as a single log. Log base b of m times n. The second one can be rewritten as log base b of m over n. And you can think of this as our exponent rules. When you're multiplying like bases, you add. When you're dividing like bases, you subtract. It's kind of working the same. When you multiply, you add. When you divide, you subtract. This last one is a new one. If you have a coefficient in front of your log, you can always bring it up as an exponent. So it looked like this, log base b of m to the k power. Any questions on your log laws? Okay, so we're going to go both ways. Most of the time we're going to be doing this, giving this and condensing, giving this and condensing, giving this and bringing up. We use this a lot when we solve. There are some time at the end of the notes today we're going to be going backwards. I'm going to be giving it to you in this form and you're going to be ripping it apart into this form. Okay, some things I want you to recognize. There is a difference between this, this and this, log base b of m times log base b of n. These two things here are not the same. Do you guys see that? This here is the product of two logs, and this is the product, this is log with one log with m times n, not two logs being multiplied. So do not try to use this into this log. Same thing here. This is different from log base b of m over log base b of n. Do you see the difference? This is a log divided by a log, and this is log of a fraction. Not the same thing. So do not try to use either one of these things. Do not try to make them into your log laws. Okay, got it? All right, any questions here before I move on? Does anybody need this page up a little bit longer? Okay. I'm moving on, and I'm going to write up here, write as a single log. Number 4. Okay, 1/2 times log base 5 of 49 minus 1/3 log base 5 of 8 plus 13 log base 5 of 1. Okay. Now, what I'm going to do here, first thing you always do is bring your coefficients up. The 1/2, bring it up as an exponent, so it's 49 to the 1/2. Bring this up as 8 to the 1/3. Don't bring up the negative sign. That negative sign, leave it there. Just bring up the 1/3. Here, bring up the 13. Technically, you could bring up the negative sign and change that to plus, but that's just more complicated. Okay, so here's what it's going to look like. Log base 5 of 49 to the 1/2 minus log base 5 of 8 to the positive 1/3 plus log base 5 of 1 raised to the 13th power. What does a 1/2 power mean? Square root. Can we take the square root of 49? Yes. If it helps you, you can first rewrite it so you know what's going on. It looks like this. And this one is going to look like, what is 8 to the 1/3? How do I rewrite that? Cube root of 8. And what's 1 to the 13th power? That we can calculate. What's 1 to the 13th? What is it? What's 1 times 1? Times 1? Times 1? Times 1 times 1 times 1 times 1 times blah, 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 blah. What is it? It's 1. Okay. And my answer is not 1. I don't know why I put a 1 there. Right there is the 1. Log base 5 of 1. I put the 1 in the wrong spot. Sorry. All right. So here I'm going to evaluate. You don't have to do this step if you can do it up here in your head. What's the square root of 49? So log base 5 of 7 plus log base 5 of what? Cube root of 8? What's the cube root of 8? 2 minus what is log base 5 of 1? I'm going to leave it like that because I want to condense. Okay, yes. That was not intentional. I don't know why I did it. Thank you. Okay, now I'm going to go from left to right and just doing first 2 and then the next ones. So I'm going to condense these to a single log using my log laws. Look back at your log laws. When it's subtraction, I condense it to multiplication or to a fraction? Fraction. So it's going to be log base b of 7 over 12. The negative's gone because I made it into a fraction. The subtraction sign told me to make a fraction. The subtraction sign is gone. Okay, plus log base 5 of 1. I'm going to condense these, but can anybody tell me what log base 5 of 1 is? 5 to what power is 1? It's 0. So really, if that is 0, that should be my answer, right? Yes or no? If this is 0, is that my answer? Should be. I'm still going to condense it just to see what happens. I'm going to condense its addition. So what do I condense it to? Multiplication or fraction? Multiplication. So log base b of my fraction, 7/2, times what? I didn't change it to 0. I left it in log form. What do I get? Times 1. And what does that, what's 7/2 times 1? What's 7/2 times 1? So log base b of 7/2 is my final answer. Is that what I said I would have gotten earlier? 5, sorry. Log base 5 of 7/2, getting carried away. Okay, is that what I said I should have gotten earlier? Same answer. I just condensed it just to show you that the rules do work. Questions so far? Okay, so I'm going to move on. We have about 10 minutes, is that right? Okay, so this is a big part, and this is on the test, so I want you paying attention. Given log of 4 equals m and log of 6 equals n, evaluate in terms of m and n. Evaluate in terms, oh, that's not supposed to be an S, in terms of m and n. Okay, now a few things when you're doing this. When you're doing these type of problems, these are special problems. You should know you're going to always use your log laws. If you don't use your log laws, you're doing it incorrectly. The second thing you need to remember is there is always a should know. You should know this. I'll tell you what that should know is in just a second. Okay, so there's always a should know. You should know this. All right, before I give you the should know, the properties you're allowed to use is multiplication, division, and exponents. And I'll explain why. You're allowed to use multiplication, division, and exponents. You're not allowed to add and subtract. Your answers will come out with addition, subtractions, and coefficients multiplying. but not in your initial workspace. Okay, so what's the should know? You look at your base of the original logs given. What's the base here? It's not written, so what's the base? So your should know is log base 10 of 10 equals what? 10 raised to what power is 10? What does it equal? 1. Now, I only wrote it this way because the base was 10. What if the base was 5? I would have log base 5 of 5 equals 1. And what if the base was 7? It would be log base 7 of 7 equals 1. Make sense? If the base was 8? Exactly. Thank you. So whatever the base is. Okay, questions before I move on to the problems. All right, number 5 is log of 24. Now I can use my rules up here because the base is 10. Now here's what we're going to do. Up here, I gave you multiple logs and I did all my log laws to condense it down to 1. This one, I'm giving you 1 log and you're going to use your logs to rip it apart. Not as complicated as up here, but we're still going to rip it apart. So we're starting on this side and I'm going to condense it, or not condense it, expand it out to this side. Ripping apart, remember that. When you see these problems, think of ripping them apart using your log laws. Okay, so here's what we're allowed to do. What you're going to do is ask yourself how to get 24 using the 4, the 6, or the 10 from the should know. So you're allowed to use 4, 6, and 10 using multiplication, division, or exponents. How am I going to write the 24? Rewrite. Log of what? Times, divide. What are we doing? Okay, so log of what times what? 4 times 6. Is 4 times 6 24? Okay, now the mistake kids make is, oh, my answer is m times n. No, your answer should not have multiplication. We only use that in our workspace. Your answer should have addition or subtraction, something like that. Have I ripped it apart yet? Remember, you have to rip it apart using your log laws. Log of 4 plus log of b or minus log of b? Plus, because it's multiplication. Now that I've ripped it apart, now I'm ready to plug in. There's no exponents to worry about, so I can plug in. What is log of 4? What's log of 6? M plus n is our final answer. Your final answer should not ever be m times n. It should be m plus n or m minus n, something like that. Not m over n or m times n. Okay, number 6. Log of 1/4. Log of 1/4. There's different ways of doing this. One way is rewriting 4 to the negative 1. Is that correct? Is 4 to the negative 1 1/4? Okay, so 2 choices. You decide which one you want to do. Rewrite that as 4 to the negative 1, and then you can use log law number 3, or leave it as a fraction and use log law number 2. Your choice. What would you most likely do when you see that one on the test? Leave it as a fraction and write it using log law number 2, or would you rewrite it as 4 to the negative 1 and bring the exponent down using log law number 3? What did you say? The first one I said, as a fraction? Okay, so using log law number 2, this is a fraction. Remember, I have to rewrite it. I'm going to rip it apart. Log of 1 minus log of 4. Is that how I would rewrite it if this is a fraction here with my log? Yes or no? Okay, I don't have log 1 as one of the should knows, but it is something you should know. That's base is 10. 10 to what power is 1? We did that one earlier. 10 to what power is 1? 0. So this equals 0 minus log of 4. 0 because log base 10, 10 to what power is 1? 0. Here, log of, I didn't mean to write minus log of 4, I meant to put the letter. What is log of 4? What's log of 4 equal? What letter? M. And 0 minus m is negative m. I'm just wondering, did anybody use log law number 3 instead? Did you get the same answer? Yes, it comes out because 4 to the negative 1, you bring the negative 1 exponent down to the front, and you end up with negative 1 times m, same answer. Your choice. Okay, number 7. I'm going to do these quickly. 7 is log of 2, and 8 is log of 60. Okay, this 7 kids struggle with a lot because how in the heck am I going to get 2 using these 6, 4, and 10? 4, 6, and 10. This way. I'm going to show it to you and hopefully you remember it next time. Is the square root of 4 the same as 2? And is the square root of 4 the same as log of 4 to the 1/2 power? And I can use exponents. But I cannot plug it in yet because I have not used my log law yet. What does the log law say to do to the 1/2? Bring it to the front. And what's your answer? 1/2 times the letter you put it in. Hello, Mrs. Torres. Okay. Bye-bye. Okay. Get the last problems from a friend or from Google Classroom and make sure you're doing worksheet 3, 1 to 33. Okay, so 1/2, what is my final answer? 1/2, what is it, M? Okay, this one has no addition or subtraction because I wasn't multiplying or dividing, I was square rooting.
So, like, it's typically 1/2 multiplied 2 times, but it's okay to have multiplication as long as it's not the variables.
Correct, correct. His question was, I said earlier you shouldn't have them multiplied. Here I'm multiplying, but you're right, I can't have the variables multiplying, like m times n is not okay. 1/2 times m is okay. All right, 60. This is the one where I'm going to use my should know because it's log of 6 times 10. Do you agree that 6 times 10 is 60? Okay, so I didn't use the 4, so it's log. I have to use my log laws. Remember, ripping things apart. Log of 6 plus log of 10. Do you agree that's what I would get using my log laws when I rip them apart?
Yeah.
What's log of 6? What letter? Plus, what's log of 10? It's not a letter, it's a should know. What's log of 10? 1. N plus 1 is my answer. Any questions? Don't forget you're doing worksheet number 3, 12.3, numbers 1 through 33 all.